Good afternoon. Happy Wednesday afternoon to you. This is the GROW meeting at IETF 92. If you think you're at a different meeting, you should leave. If you'd like to stay for GROW, that's great too. We're going to get started in just a minute. There's blue sheets going around. Please take the time to sign the blue sheets. Do it 3 times so we get a bigger room next time. No, don't. Just once is fine. We have 4 presentations, a little bit update about current drafts and things in progress, and then everybody will be able to go home. Well, I mean, back to wherever you were before here. All right, sorry, that's the note well slide. It's an eye chart intentionally. I'm sure you've seen it several times. I changed one word in there. You have to go find it. So anybody else have anything they need to add to the agenda? Going once, going twice? Okay, good. Quick draft status. We have 4, actually I think there's 6 things that are currently flying around in mid-process. The filtering threats was updated in February. I think actually maybe, yeah, February. The error handling document, I think actually, Rob, you sent an update for this in recently. Or is it, yeah, not the November, but like in the last week or 2? Or no?
No, I think it had expired.
Oh, so you...
It's not expired.
Okay. Right. So I should also have said earlier on, we need to pick up somebody take notes and a JavaScribe. 1, 2. Note taker, Jared? No? Okay, great. We got note taker and a JavaScribe, perhaps? No. Jared can JavaScribe. Great. Excellent. All right. So backing up again, we have draft status.
This one's in last call.
Oh, Peter put a last call in for the GROW filtering threats last night. The error handling document was refreshed by Rob, and he's looking to get it last called and out the door, hopefully after this meeting, provided there's no substantial comments at the mic today. The route leak problem definition, Sriram had an update a week and a half ago, and he's going to say a bunch of stuff about it a little bit later today. Thanks. Then there's some expired stuff. GROW BGP shut. I think that this might actually be waiting on something from the chairs. I have to talk to the authors, and unless there's one of them around. The GROW RPCL via also expired, and so did the leak attack no help, BGPsec no help. That expired in favor of Sriram's draft, I believe. So unless somebody wants to argue about that, we'll leave that one go. Next. There's 2 that are in processing. The route policy considerations is in IESG processing. I don't remember what the exact status for that is. And then the route server operations is in the editor queue, so it should pop out as an RFC at some point in time. And then we have a bunch of presentations. All right. So there's the same story as last time. There's a pink box. Yeah. Stay in the pink box. Talk to the mic. Do you want to present?
Yeah.
Okay. It's going to be harder for you to be in the box and also present, but. Oh, I can move then. I'll stand in the box and. Here, let me. Trade seats.
Push a button on the thing because it doesn't work.
Thank you. And should I use this one?
Yeah.
So my name is Yasuhiro Hara from NTT, and this is the introduction of the BGP dump 2, which I developed. This is the tool to read the root dump. So the motivation is that we are saving full routing table in root views project and write NCC mainly, and they is saved as a file. So this is the new tool to read those routing tables. It is beneficial if we analyze those full routing table to the health check and or the molded in the future routing table shape. So as an ISP, I belong to the ISP. So I wanted to know how we are doing by comparing the BGP full routes. And also, in doing so, I wanted to modify something. So I developed it from the scratch. So this is the kind of but rip dump files, how we save them. Like this is the collector, and target AS is called route monitor, or the target AS BGP speaker is called route monitor, and we call it as a peer in the rib file. So there is these list of existing tools, but I created a new one. Yes, 30 minutes ago I succeeded to support the gzip so that we can read the right sorry, right rib file as well in using this tool. So what's good in this is just this is the simple example of the simple display, and we have a partial compatible mode with the BGP dump. The community and local prefer those are not yet shown, but briefly it is compatible right now. And we can show the display, we can show the peer table and per peer routing table and per peer statistics, like how much, what number of routes is contained in each peer, and what is the distribution of the prefix length, like of course the /24 is the most biggest one, but how's the distribution? And also I wanted to know how much next hop it includes, and mostly they are one, but sometimes depending on the configuration, some files includes up to 200 next hops in their rib file. So this is the speed. Like if we adjust bzip cat, this is the lower bound, we're gonna take 30 seconds. If we are using zebra dump parser, it's gonna 430 seconds. If we are using libbzp dump, it's gonna be 150 seconds, and ours are 90 seconds. So a little bit advantage in the speed. So I created the diff option, which is kind of like a unified diff. Like if we specify 2 peers, and if the route is the prefix is only shown found in the left peer, then it's going to be minus sign, and if prefix is only the right side, then it's going to be plus. And but when we see this, actually the next question come up will be we don't have this prefix in the left peer, but should the shorter length prefix covers this range, so it's not that in the left side, left hand pair, there is no reachability to this prefix range. No, those kind of in order to answer those kind of questions, we're going to need a longest matching search. So I created, my tool can construct the routing table using published here. And like if we are specifying peer 19 and look up for one address, then it's going to be like this. And we can specify as a file, like the file contains the four address, then look up one by one. Then some of the prefix address is not found in the routing table. So what we can do is to now we can compare the reachability if the left hand side peer actually lacks the reachability or not. We can consult. So I extended the marks, like if the plus is appear, then it is reachable, but it's only in the right peer, kind of like that. And if the prefix is in left and have not found in the right side, then it's going to be this is the greater than, right? This sign is shown. And after that, maybe partial route can be found. Then it's going to be using the right parenthesis. So it is, yes, it is, I thought that the right parenthesis is directing to the right in not edgy like. So it's gentry, right? I don't know how to say it. But so this is the example. So if we are comparing our ISP and level 3, then this prefix is only in the level 3, but we have some partial routes. So this is the how we can see. And using that feature and just ignoring the partial routes and filtering the missing route, like the left hand side is our route, and right hand is all the other peers that is existing in this file. So this is to compare the entity's route with each of other ISP's route. That is what I wanted to do. And these are the missing in the entity, the prefix missing in the entity routing table. Like there was kind of 60 peers in the file. Some of them were empty, but 38 of those peers have this prefix, but the entity doesn't have. So it might be a kind of difference in the full routing table. And if we unique by the organization name, this is the ranking of the organization name. Like the first one is some Taiwan network, and the next is the Voxelity from Romania. I confirm that those two prefixes or the organization is can be found in the global routing table of the entity. But somehow in the Oregon's root view is not having the routes. So even in one ISP, there would be some kind of versions, and if we were focusing on the route views, Oregon's route view routing table, then there is a difference between the global entity routing table and Oregon's root views entity routing table. So I didn't check about the third, but for the fourth, this is kind of eye-catching. So I asked talented entity operators to track down why is we don't have this Time Warner cables purpose. It is confirmed that also in the global routing table, some of the purpose is not there. So we are asking. And also as for the voxelity from Romania, some of the Asian network doesn't have reachability to the voxelity, even though the NTT's global routing table have it, because they set the community tag, which that means do not advertise in Asia. So I'm wondering, this is not the original intention of the voxelity itself to set these tags, not to provide the reachability to the Asian network. So we might need to contact the voxelity's operators about this. And there are some other nice features, like if we are concerning about the number of routes in the full routing table, we can have easily we can show the number of routes in many rib files. Like if we are specifying multiple rib files, then it's going to be shown like this, one line per rib file. So and the timestamp is the first one, and this is the peer 1, this is the peer 2, this is the peer 3, so that we can easily create these kind of figure, like this is the peer 0, this is the peer 1, and so on. No. And this is another example of the analysis. We compare the two rib files from different time, and for the same peer, we compare the difference of the distribution in prefix length. So from August 12 to August 13, /16 is decreased 47 by 47, and /23 increased in 66. This is like that. And yeah, this is another from August 13 to August 14. The /24 is increased in 500. And we can choose arbitrary time range, like it's depending on what rib file you specify. So this is the 1 week range, including those 2 days. So there is one thing I'm concerned creating these kind of figures, because it depending on the peer ID is the same for the same peer identity. I mean, if the entity is peer 19 in the previous file, then in the next file the entity is also the peer 19. But sometimes the peer is changing. This is the implementation issue of the Quagga, I think. But if we are searching for entity in the file for this is the output from the three real files. One is the 20 and peer 20 and peer 21 is the entity, but sometimes 21, 22, 19, 20. So in this case, it's going to be more harder to create those kind of figures. And as a discussion, the first line is the same. The peer number is changing. And in doing the full routing table, I run into some philosophical question like what is the BGP full routing table? Even in one ISP, there is a version of depending on the area or region. So maybe the common set of the many version of the from the ISP or the among the ISPs might be interesting. I thought in the random thought, and I'm thinking that we can evaluate the ISP's quality of routing by comparing the BGP for routing table. But I don't know how exactly, like just diffing two routes would make you run into some detailed specific case debugging. So I don't know what is the, we can say this is good or this is bad for this kind of thing. And I think this tool is already contributing in some sense, like we triggered for a specific, the debugging for specific routes from the output of this tool. So I think the tool is already beneficial, I think. Features to be added is like regular expression in ASPA and also regular expression possibly on next hops. This is suggested by Mr. John Kemp. And also I heard that the matching ASPath and also matching in community tag is not supported by one router vendor. Like I thought someone was saying Juniper, but I don't remember. These these kind of tools might be contributing helpful, I think. And also we're gonna need a name resolution using Team Camry is providing the DNS interface for the name resolution of AES number. So I might be using this one. So this is the last slide. BGP dump is developed from the scratch, and that can be used to compare the reachability of the two routing table using the longest matching feature. And I'm open to the feedback. Please use. I haven't told you, but it is already in the GitHub, so you can use from now on. Thanks.
Do we have any questions, comments?
Hi, Colin Petrie, Ripe NCC. The issue that you mentioned with the peer index entries, varying over time. And you suggest that perhaps that's a Quagga bug.
I don't call it bug, but yeah.
Well, my understanding of it is that depending on whether or not a peer is actually up, or
Right,
whether
right.
new peers have been configured, they get the numbering in the dump files is always sequential. So if a peer is down or one has been removed, then it's going to reorder itself. Were you seeing this in situations where the same number of peers were always in the index table? Were you seeing the peer move around with the same set of peers?
I didn't check, but I believe the number of peers are increasing or decreasing when the ID is changing.
Right.
Yeah.
Okay.
So yeah, I think what you explained is the what is happening. I think yes.
All right. Thank you for your presentation. I think Rob, you're next. Thanks. Don't move. Outside the box.
Getting told to get back in my box. I'm quite used to that, I think. Do I get some slides?
Yeah.
Yeah. So I'm going to talk a little bit about this draft, which was the operational requirements for error handling, and I thought I'd start with a bit of history because I actually wrote this draft in 2010. So in 2011 it got published. I took it to IDR in the first meeting there, and it then went into Grow. It's been in Grow since. The idea was to try and put forward some operational requirements for changes in BGP error handling. Since then, we've kind of talked through a bunch of those requirements. We've talked through a lot in IDR. We've reached some form of consensus around a set of drafts, the solutions, but still we haven't managed to entirely finish off the requirements draft. And partially that's me, and partially that's the fact that there has been a lot of debate, and especially some of the debate has been around implementation issues when people have come to actually build the features. So next slide, please. I think that the key ideas that are in this draft have been stable for a long time. They're really around defining a set of errors that can be defined as non-critical. So we don't tear down the session. We do something to handle it instead. Some things that are still going, some errors that still happen, and we want to tear down the session because there's no way to recover from it. And defining error handling that sits for both of those different approaches. One being the things like treat as withdraw, and then the other being how to reset a session with the least hit to actually carrying traffic over it. When we've also been through a working group last call, we went into IETF last call for this, and one of the feedbacks was the document wasn't very clear. So I actually since then have also done a complete rewrite of the document to make it a lot clearer, and it kind of suffered somewhat from we had a bunch of ideas and then we wrote those down and then they got added to and taken away, and the document wasn't necessarily easily consumable anymore. The main clarifications were mainly thanks to Bruno, I think, which is around defining more clearly where the different scopes of errors that we had were around. Is it an attribute error? Is it a message level error? Or is it a session level error? And then I've taken those and linked them back to the two kinds of error handling behaviors, which are the non-critical and critical ones that we had before. Next slide, please. The other thing that we added in later revisions was there's some debate around what should an operator do when you have a really long-lived error that you can't really do anything about, especially when it's remote to you. Do you just live with, and especially when that's also a critical error, so the session is continually being torn down. So we've added in two different potential solutions that there seems like there's some operational support for from the various discussions. One is the long-lived grace or restart, which was called persistence before, and then the other is a method of last resort where it is possible to say, I know that there is a problem on this session, I can't do anything about it, and I would like it to stay up, as a knob to be used in emergencies, such that you can at least retain some form of connectivity when something can't be filtered. Next slide, please. So I think I've addressed all the comments that there were for the 06 version. In the 07 version, there's one minor editorial set of changes that need to be made. As I said before, we've been through working group last call on this. I think there's consensus here. If I were to call a consensus based on the fact that no one really shouts anymore, which is that was really the big problem before. So the lack of shouting, I'm assuming, is people being happy rather than people not caring anymore. If that's not the case, then I would like to be corrected. I would really like to publish this work because 5 years ago I started this work, and I think we've deployed it in our network. We've learned a bit about it. It's in most major implementations, stuff that's come from this work. So, and it seems kind of broken to me that we have solutions published without the requirements, which kind of motivated them necessarily reaching the same level of maturity. So if you don't think this should be published, then I would really like you to shout at me now. If you think this should be published, I'd also like you to shout when there's a last call so that we can progress it. So I think this is some good output of this working group. There's been a lot of input to this document from a lot of different people. I think it'd be useful to record that.
Raise a hand of who's actually read the latest draft. Okay. So it's not. Yeah, I think we'll have to go to the list, and I'm guessing it's probably ready to publish, but we have to go through the list and.
I will
make sure
have a
people
party in Prague if we do, right? You're all invited.
We probably need to find a few reviewers just to go make sure that it goes through before we do last call.
Yep.
Because it has had a major revision, and not many people have re-reviewed it because I think they agreed with the original one, and the wording's probably better. Yeah.
Yeah, Joel Yegley. Yeah, I mean, I think we'll probably try and get some early feedback from, well, I shouldn't say early because it should have been about 2 years ago, but early feedback from the routing ADs when you get to the point of calling it a working group last call, so that we can get square with the other sort of communities of interest on this. That's my only thought.
Cool, perfect. Well, I'm shepherding the IDR document, so I'll also go to people who made comments there and see if they've got comments on this.
Yeah, and I expect you to do the routing area review on your own document too. But you know, we'll cross this bridge when we get to it. But I don't think it will be a huge problem. It's just we have some work to do there.
Perfect. Thanks.
I think we'll probably put it out for last call and see and make sure some people review it for last call and go from there. Thank you.
Magic. Thanks.
You're up. Go for it. Yeah. I was going to do the other one, but yeah, I'm toggling through the screen, so. Okay.
Okay, so let's go. So this talk is about doing some timestamping within BGP. So this is a work that we started in IDR. So the first version was presented in Toronto, and I was presenting yesterday some updates. But I'm pretty convinced that at least some part of this work is really kind of operations of BGP. So it's really important to present it here also. So what is the problem that we are targeting to solve? Today we are sending some path within the BGP control planes, and sometimes these paths are propagated quite quickly, sometimes not. And we don't have any machinery that is able to monitor this kind of performance of the BGP control plane. So what we are trying to do here is to provide some kind of timestamping within the BGP control plane and let, so we are creating sort of timestamp vector within BGP. So if I'm positioning at some BGP speaker that is receiving something, I'm able to receive all the information about what has been the propagation time at each BGP speaker. So next slide, please. So why it is important today? I think the most important reason is BGP path propagation is really important for convergence. Robert, you don't agree. It depends on your service. For example, if you have some multicast VPN, you need to send something to be able to join the tree, and you need to be able to send it very quickly. this is one of the use cases. If you have some layer 3 VPN and you are relying on convergence because your at least your SLA is not too much critical, so you can rely on it. Your BGP update must not take at least hours or minutes to be received by the receiver. No, don't smile, it's happening. So we are clearly facing some issue in operational network at large scale with BGP propagation time. So it sounds really important for us to be able to monitor it. It's becoming more and more critical because we are more and more services that are using BGP. So before we had only internet, then we had layer 3 VPN, now we are doing layer 2 VPN, eVPN, multicast VPN using BGP. And from an operational point of view, as operator, we would need to be able to mix all of them in the same boxes for CapEx reason and cost optimization. So it's really important to ensure that by mixing this all is still working fine, because all the different services have different priorities. Some are critical, some are less critical. So we need some tool to be able to monitor this, the good behavior of the control plane. Next slide. So the requirements. So we need something to be able to monitor this performance. In terms of, I would say, orchestration, I would need something that is really simple. I don't want to establish multiple sessions to each BGP peer and then try to correlate information by, okay, I know my topology, I know that this is the first route reflector, this is the second one, so this one need to receive the information first, and the other one, it's really complex. It's complex within an IS, and if you want to do it in inter-IS mode, it's even more complex. So what I want is, okay, I'm triggering some probe at a point of the network, and I want to receive the information at some different point of listening, and then being able to analyze what's happening in the path propagation. So single point of listening is something that sounds really important. The other point is I need to, as I said, be able to gather information about what is happening in between, so at each BGP speaker. And for sure, we need a solution that is quite accurate in terms of being able to measure this timestamping. Next slide. So the solution we are currently proposing in IDEA is based on a new BGP attribute, which is called BGP timestamp, which is simply a vector. So each BGP speaker that will receive the path and we send it to some other BGP speaker will add some information about when it received this information and when this send operation has been done also to the next BGP, to the next BGP speaker. So if you look at the diagram here, so for example, C1 is sending a BGP update for a specific prefix. It's adding some BGP timestamp information, and then each speaker in between the originator and the listening point will add subsequent information within the vector. Next slide, please. So for sure, the scope we are targeting is not to timestamp everything. At least in my opinion, this is not necessary. We already had some internal machinery to try to measure this BGP propagation time within a live network without using such extension, but it's a bit complex. But okay, we have something that is currently working. And what we see is that by using some probes, so I'm sending some prefixes sometimes, so I'm sending, withdrawing, sending, withdrawing from different points of the network, and we are doing some sampling, and it's providing already pretty good information. So we want, so the solution is really targeted to be done on some very specific prefixes that will be sent and withdrawn. and sampling sounds to be a good solution for the measurement. So next slide. So for sure, we want something that is able to run inter-AS, because, for example, in our use case, we are owning multiple ASs, and we want to be able to monitor propagation time between ASs. We considered some kind of, I don't know if I can say really security issue, but sometimes you may, if you are talking to a partner, for example, you don't want to expose your internal topology and your internal timestamp. So we are providing some ability to drop the timestamp information or aggregate the information to say, okay, the timestamp within my network is just the entry point and the last point, and you are hiding something, all that is in between. So this is something that we are currently considering. So depending of the use case, it's useful or not. This is something that we can discuss. Next slide, please. So the next step. So at least as a service provider, we think that this is something that is really necessary to be able to monitor this performance. In terms of solution, we are proposing a solution. Is it the good solution or not? So this is something that we can discuss. I mean, it's maybe some pros and cons. So we are clearly welcoming your feedback about this. And in terms of work, the question is, do we still need to continue this work on IDR only? Do we need to home at least maybe the problem statement and requirements in this working group and split with solution and encoding maybe in IDR? Personally, I don't care, so this can be discussed.
Doug Montgomery. So are you proposing to timestamp things upon receipt or upon best path selection and transmit?
Receive and transmission.
Both.
Today, both.
Okay.
We started with only receiving, and in Toronto we had some comments that doing it also in the sending process is useful, so we added it.
Actually, I think it's the only place that it's useful, or at least, you know, a route could sit in your ribbon for weeks until it's selected as best path.
I agree with you, but as I mentioned, the target is really to have some kind of probe prefixes. So they will be received and automatically selected as the best path and exported. You see?
I see.
You just answered the questions.
Any other feedback?
So did you present this in IDR already?
Yes, well, first time in Toronto, and yesterday also for the encoding update and procedure updates.
So it's only for probe prefixes?
This is what I'm targeting, but we can discuss. I'm open. Do you see a really interest to do it, for example, for all your prefixes?
Well, not all, but some that are actual prefixes, sure, why not?
You can do it.
Well, maybe that's an interesting question. I mean,
It works with both.
right. So you're just proposing an attribute that if you dropped it in a path that was for a real prefix, it would do its thing.
Really, Volk. Well, okay, for the production prefixes, actually what you would be looking at how old all those are. You don't want the production prefixes flipping around all the time, and demonstrating how well you are doing the conversions.
Okay, and I think we need to probably talk offline about it and decide on a way forward. And so we would talk to you about
Okay,
that
sure.
and go from there.
Thanks a lot.
All right. Yeah.
So I'm Sriram from NIST. So the problem definition document in Honolulu, we presented an individual draft version of it, and subsequent to that, in GROW, it's been accepted as a working group draft. So this is the working group draft version. Next slide, please. So compared to the previous version, the diffs are, we have added 2 new types of route leaks, and that was based on comments that we received in the hallway in Honolulu from Andre, as well as Brian Dixon. Essentially, they thought that previously the 5 types of route leaks that we did the classification earlier, we put it in 5 different categories or types. They thought that it would be more complete if we looked at some other work and thought about that and see if that list is complete or something could still be added. And we have also added several relevant new references. Next slide, please. So we had types 1 through 5, which I talked about and described in Honolulu. And since then, type 6 and type 7 are new, again, motivated by comments from Andrea and Brian. Type 6, we can, I guess, go to the next slide. This is my last slide, just to give you what is new in the new version of the draft. Type 6 is a leak of provider prefixes to peer. So this happens when an offending AS leaks prefix routes learned from its provider to a lateral peer. And type 7 is a leak of peer prefixes to a provider. So typically, the prefix has originated from a customer cone, it goes to an ISP, and the ISP gives it to a peer, and then that peer shouldn't be transmitting it upward towards a provider. So these 2 types have been added, and just like we had real world incident examples for each of the previous 5 types, there are such examples for these as well. So type 6, what Jared March observes, where he sees 3 ISPs in a sequence in the AS path. So some of those are type 6 kind of leaks. And type 7, if you take, for example, the Dodo Telstra example, the prefixes that a whole bunch of thousands or hundreds of thousands of prefixes that Dodo passed on to Telstra, they included not only the prefixes that were learned from providers, but also from peers. So that, I believe, like makes it reasonably look good in terms of classification based on all the real world incidents that we have been able to catalog and look at over the last several years. So if you have, I mean, I'm sure there can be other definitions of route leaks which are not included here, but we thought that these are critical. They have made news every now and then, and so based on that, we have this classification for now. And if you have feedback that to add to this or make any improvements in the draft, it's most welcome.
Jen Linkova. I read the draft and I'm kind of surprised to see that in the type 2 you are referring to still in the internet presentation, because and at the same time you're saying that the IS path is not modified. I think what was particularly interesting in the still in the internet DEFCON talk, that the attacker modified IS path to make sure that IS is on the path to the victim could not see the announcement.
Type,
I mean, okay, so type 2 is U-turn with more specifics.
Say it again.
U-turn with more specific prefixes.
Right.
So I think if you are referring to DEFCON talk, you probably should say that IS path is modified. Probably it's a different type of leak.
Because the sub-prefix is modified, you are saying the AS path is modified?
Yeah, in that particular case, which was described in DEFCON talk. attacker modified the IS path to make sure that other network could not see the announcement.
So I don't think there,
I happen to be
any
there on
AS
the
was
talk,
inserted
I
or deleted, right? I mean, no AS was in, no AS was inserted or deleted.
They inserted the ISS which are on the path between the attacker and the victim.
Yeah, that is.
Over the Erfolg. Actually, I think the path, the maliciously ejected announcement was manufactured. If the actual prefix that's being announced changes, this is not leaking of a route that's somewhere. It is actually manufactured, and that it actually copies parts and modifies parts of announcements that are there. Does not really match my definition of leak.
Okay, so our intention was to see if I mean, there could be malicious leaks, and if a malicious leak were to happen, you could modify, you could pretend that the whatever, I mean, yeah, you could change the prefix to a sub-prefix. So it could be intentional, just to make the traffic flow through your AS. In which case, in which case the traffic does indeed go through the AS, so it has the same effect as a regular leak with a full prefix. So you could have intentional or malicious leaks, and that's where the sub-prefix, the type 2 comes in. And then we talked about prefix hijacks, right, where the reverse path to the legitimate destination is still available. So there again, there have been like examples like Belarus and Iceland, where the prefix with the whole path was leaked. Sorry, it was hijacked, but then and China Telecom as well. So it was. If you don't want to call it, you can call it re-originated, accidentally maybe, but.
It's not clear that that's what happened, though, right? In at least the Iceland and the China Telecom cases, the routes were simply like squeezed out the wrong hole, right? They were just leaked through. There was no re-origination. They just passed the route on
so
with
maybe
poor filtering on both sides.
So the full path was present all the way.
I believe so, yeah.
I need to refresh.
If somebody in here knows more about this, that would be great if they would stand up and say something to contradict what I said. But I'm pretty sure they just leaked out due to poor provider filters.
Yeah,
Aha! Yes, hero.
I think you are saying in the draft that you are not trying to list all of the route leaks types. Did you?
Yeah, it was not our intention to try and capture everything that somebody may think of as a route leak, but we looked at a whole bunch of incidents. If you look in the references, there are maybe approaching 30 references which talk about different types of incidents that have been called route leaks. And so we looked at all those, and then we tried to come up with the categories that describe those.
My comment is it's going to be better if we can list all the route leaks in the draft, right? So yeah, kind of just not trying to list all the types or as we know it kind of thing is all right, I think, but just not trying to
exclude them.
List all is, we better to list all.
Yeah, we didn't deliberately exclude anything. We just thought that what's being talked about as route leaks in the press, etc., that's what we went by. Doug.
Doug Montgomery. I'm not sure I understood the last comment, so trying to make sure we list all leaks will guarantee that we will present a new version each time we come here. But So the taxonomy was devised to look at various characteristics of incidents. You could choose different characteristics. So if you wanted to differentiate things that we call type 2, the ones where there doesn't appear to be path modification, I mean, that's another taxonomy, another dimension in which you could separate those two. So there's more specific sort of leakages, and then more specific leakages with path modification. So if that seems to form a useful class distinction, one could talk about doing that. I also think there is a purpose to just building a functional taxonomy of many of these, but not saying that it covers everything you could possibly call a root leaf, because I think that's an infinite set of things.
So yesterday we presented the detection mitigation draft in IDR, and so the solution that we had, we were able to extend it to route leaks of type 6 and 7 as well. So that's the status of the things. Please do let us know. If you have if you feel strongly about any of these classification, please send us a message, post an email on the list, and we'll be happy to discuss that. Okay.
Okay, thank you.
Thank you.
So looks like that's all we have for today and this IETF. We will see you in Prague, I believe. So, thank you.